Gear up and get ready. You're watching Engineering Talk, where we turn what if into how to. Let's dive in.
Hi friends! Today we're learning how soil plays a super important role in building strong and safe highways.
You know, we spend so much of our lives on roads, but we probably never think about what's actually underneath them. So today, we're going to dig into the invisible science that's holding our world together, the really complex engineering hidden just inches beneath the roads we drive on every single day.
Oh, you've definitely felt it, right? That sudden, jarring jolt from a pothole. Or maybe you've seen that spider web of cracks spreading across the asphalt. It just makes you wonder, why can't they build a road that actually lasts? It's a frustration I think we all share.
And you know what? We love to blame the heavy traffic and the crazy weather, but the real problem often starts way before the first car ever drives on it. The true culprit is often the ground itself. And that brings us to our first major point. When it comes to highway engineering, the surface you see is only ever as good as the foundation you don't. Literally everything starts with the soil.
See, to an engineer, soil isn't just dirt. Nope, it's a full-on construction material. It has to be strong enough to bear immense weight, it has to resist shifting, and it has to guarantee the safety of the entire road. The properties of this one material, the soil, will dictate absolutely everything that comes next, from the materials they choose to the final design of the road.
So to build a road that's actually going to last, engineers kind of have to become detectives. They can't just look at the ground, they have to investigate it, they have to understand its unique character and uncover all of its secrets.
And their number one investigative tool? It's a field called soil mechanics. This is the science that lets them predict how the ground is going to behave under the incredible stress of a highway, from all the pressure and weight to constant changes in water and temperature.
This whole investigation follows a super clear three-step process. First, they profile the suspect. They figure out exactly what kind of soil they're dealing with. Then, they interrogate it with a whole series of tests. And finally, they use all that data to build their case for the final road design.
All right, step one is profiling the suspect through classification. Engineers use these standardized systems like USCS and ASHTO to group the soil based on its physical traits, like how big the particles are and how it reacts to water. This is the absolute first, critical step to knowing exactly what you're building on.
Okay, now for the really juicy part, the interrogation. This is where engineers put the soil to the test to figure out how reliable it is. And they're focusing on two key things: its relationship with water and its fundamental strength. The very first test is to figure out what the soil is actually made of. It's called the particle size distribution, and it tells engineers the exact mix of gravel, sand, silt, and clay. You can think of it as the soil's basic DNA profile. So what's the ideal foundation? It's something called well-graded soil. All that means is it has a really good mix of large and small particles. Why does that matter? Well, the smaller bits fill in the gaps between the larger ones, creating this dense, tightly packed foundation with almost no weak spots. Next up, engineers have to understand how the soil behaves when it gets wet. Atterberg limits tests are designed for fine-grained soils, like clays, and they basically pinpoint the exact moment the soil goes from being a solid to being moldable like putty, and then all the way to a liquid.
And this is why that test is so important. A soil with low plasticity is what you're looking for, because it doesn't dramatically change its behavior when it gets wet. You want a foundation that's going to stay solid and stable, not one that turns into slippery, unstable mud every time it rains. Which leads us right into permeability, or, how easily water can flow through the soil. High permeability is great. Water drains away, and the foundation stays stable. But low permeability? That's a road's worst enemy. Water gets trapped, and if it freezes, it expands, and it will literally destroy the road from the inside out.
All right, so the detective work is done, the soil's secrets are out. Now what? How do engineers take all this data and use it to build a road that will actually last?
Well, the single most important technique is something called compaction. This is literally the process of using heavy machinery to press all the soil particles closer together, squeezing out air and water to make the ground as dense and as strong as it can possibly be.
And the benefits here are just massive. Proper compaction makes the soil strong enough to handle heavy traffic, it prevents the road from settling or sinking over time, and it just dramatically increases its stability. The magic number they're aiming for is at least 95% of the soil's tightest possible configuration, making it nearly as solid as a rock.
So after all this work, all this testing, the engineers get a final score. A single number comes back from the lab, 8%. Okay, but what on earth does that actually mean for the road?
That little number is the California Bearing Ratio, or CBR. The easiest way to think about it is like a grade on a report card for soil strength, where 100% is like super strong crushed stone. A score of 8%, well, that's basically a failing grade. It tells engineers one crucial thing: this soil is weak. And to make up for that weakness, they're going to have to build a much thicker, stronger, and yeah, more expensive road right on top of it.
Now, you can imagine they don't always have time to wait for lab results. So to get this data fast, right there on the job site, they use tools like the Dynamic Cone Penetrometer. It's a simple but really effective way to get a quick, on-the-spot strength test that gives them that all-important CBR value.
But okay, what happens if the verdict is in and the natural soil is just, well, it's just too weak? Engineers don't give up. They improve it. This is where something called soil stabilization comes in. They can do things like mix in stronger materials, add chemical binders like cement or lime, or even lay down these special reinforcement fabrics to strengthen the ground.
So let's zoom back out and bring this all back to the road you drive on every single day. That simple strip of asphalt is really just the final chapter in a very, very complex scientific story.
Here's the one thing I really want you to take away from all this. A good road is never an accident. It is the direct result of a meticulous, scientific investigation into the earth it's built on. Every single stable, smooth, and safe mile of road is a testament to this hidden science of soil mechanics. So I'm going to leave you with this. The next time you're cruising down a perfectly smooth highway, one without any cracks or potholes, I hope you'll take a second to think about the incredible, hidden science holding it all together. All that amazing engineering happening just a few feet below your wheels.
Thanks for watching Engineering Talk. If you enjoyed this video, don't forget to like, subscribe, and keep learning. See you in the next engineering discussion.